So I am the Space Exploration Program Scientist in the Heliophysics Division, and I'm very glad to be here. I'm here to give you a few updates on our activities, especially with regard to the Artemis missions. I am stressing the hotel Wi-Fi though, so I'm going to go video off. All right, next slide, please. My role is naturally tied in with the space weather program at HPD, but it incorporates any heliophysics activities that intersect with deep space exploration, with our goal being to support and leverage NASA robotic and human exploration of the solar system. We have already begun embarking on this goal through cross-divisional partnerships, which are shown here. Hermes is a space weather research payload that will be on the first Gateway manifest, and will measure high energy particles from the solar wind. And at Mars, the space weather community is taking advantage of radiation measurements from MAVEN, which will be joined by ESCAPADE very soon, as well as the RAD instrument on Curiosity. Next slide, please. Space weather and heliophysics science aligns very well with anywhere the sun touches, because the sun makes interplanetary travel a hazardous and risky endeavor. And I will show a striking example of that later. And as with everyone here, one of our primary focuses right now is Artemis with an eye towards Mars. Next slide, please. And we currently have 4 heliophysics science high-level objectives in the Moon to Mars strategy, which were developed to enable and leverage human deep space exploration. And these include investigations into space weather phenomena, the history of the solar system recorded in the regolith, fundamental processes and dust interactions, and also solar wind dynamics between protected and unprotected environments. And I want to stress that there is a lot of synergy between the heliophysics objectives with the other disciplines, such as lunar and planetary, human, and then also biological and physical sciences. Next slide, please. One of the exercises that we completed with cross-divisional support was to determine the data needs and opportunities to contribute to these objectives, particularly with the Artemis 2 and 3 missions. And the common thread that you can see here are radiation measurements. And I'm using the term radiation loosely to refer to photons and particles, depending on the available measurements. As noted here, radiation measurements at multiple locations are a key component to space weather and heliophysics science in general, and regolith sampling is key to understanding space weathering, dust-plasma interactions, and the history of the solar system. So for the next 2 Artemis missions, we are working with the other S&D divisions to look at leveraging data sharing opportunities that are already being planned for. Next slide. So the exciting thing that happened for us last fall was the long-awaited release of the Heliophysics Decadal. There was a strong emphasis on space weather and its role in human exploration. And the committee directly recognizes the revitalization of the crewed space missions, beginning with the Artemis program. And just taking from the caption here, which was in the Decadal, it notes that astronaut safety is critically dependent on the ability to monitor and forecast solar energetic particles in near-Earth space, as well as the lunar environment. So they recognize our integration into human exploration. Next slide, please. And here I'm highlighting guidance provided by the Decadal, but I want to stress very firmly that this is informational only, because the Heliophysics Division is continuing the evaluation of and response to the report. But as the report acknowledges the renewed interest in crewed space exploration, it also identified the need for understanding the impacts on specific systems and on humans in these hazardous environments. So objectives were identified throughout the report, both in science and in space weather, from fundamental processes, comparative studies of planetary bodies, and even habitability to space weather system responses and space weather impacts. And one of the emerging opportunities from a subpanel report specifically highlighted leveraging unique platforms and environments enabled by human exploration, including the lunar surface and cislunar space, such as Gateway. Next slide. So of course, we will be revisiting the heliophysics objectives as needed based on this renewed decadal context. However, the anticipation is that it will be additive. So for example, adding in comparative planetary studies, which would dovetail very nicely with HS2. Next slide. And similarly, one of our key documents guiding our heliophysics lunar exploration science from 2007, next slide, is due to be revisited with an updated gap analysis incorporating the renewed decadal guidance. That said, there are still numerous important questions from this document that, that going back to the moon will enable for heliophysics, including fundamental plasma and dust physics, solar wind dynamics, as well as the influences of space weather on the regolith. Next slide. The decadal also highlighted new data opportunities. So for Artemis, this includes Gateway as a platform for measuring high energy particles, which we're already planning to do with the Hermes instruments, and lunar surface exploration opportunities, starting with radiation observations and regolith samples. And it's also worth mentioning again how vital the cross-disciplinary aspect of all of these opportunities are. Next slide. And another vital component for space weather and exploration is interagency coordination. And I am really just tickled pink to be presenting this today because I actually stepped away from the Artemis 2 space weather testbed exercise happening this week, which is bringing together forecasters and users from NOAA, NASA, the National Weather Service, and DoD. And we're here to work through the coordinated responses to space weather events by practicing on known events from the past. And I'll just say that anyone involved with Artemis crew and infrastructure will be glad to have these teams watching their backs. Next slide. This I just saw for the first time yesterday. I'm going to show a movie from NOAA's very new GOES 19 coronagraph, provided with permission from Nathan Miles and NOAA. Note that this is non-operational data. The sun is indicated by the white circle in the middle. It's blocked out so that we can see the much fainter corona where the mass and radiation flow out through the solar wind, and also coronal mass ejections. The spikes are streamers, and when I play the movie, I want you to notice the mass continually flowing outward along those streamers. You'll also notice a few eruptions, one notably moving through the top of the frame, and there will be one more surprise. So let me just play it for you. So hit play, please, or the next slide. This is so fun. That is the moon. So congratulations to the C-Corps team for everything that they're getting out of this instrument so far. So next slide, please. And this sequence really does put into context the environment that the crew will be subjected to. So understanding the sun and knowing its localized influence is vital. And this image beautifully captures the Artemis mission from my perspective within heliophysics. So again, thank you to the C-Corps team. Next slide. And so we have been rapidly ramping up our engagement with the exploration programs in the last year, and the release of the decadal provides us with community support, strong community support for all of these activities. And I strongly urge helio researchers to get involved, actively involved in the community participation opportunities, and to reach out to me if you have any questions. And I just heard from Sarah that the participating scientist call won't be this year, but hopefully there will be other opportunities to be involved. So reach out to me if you have any questions. Thank you.